Hey guys, welcome to this lecture. Today we are going to see how you can allow the inbound access to any particular web server which you have hosted inside your trust zone or DMZ zone. So basically, we have this Linux server, right? So what I'm going to do is I'm going to put this Linux server inside the DMZ zone, right? So I will remove it from my trust zone and I will put it inside my DMZ zone. So let me just modify the IP address. So it will be like, let's create a different subnet. So 172.16.1.2. Okay. So this is the IP address we are going to define here. And similarly, we will add another interface on this particular firewall and we will place this server in our DMZ zone so that whatever public users we have on internet, they can access our Linux server, right? So we will create a DMZ zone for this. So let me just do one thing. Let me make some space. So this is my trust network, right? And this is going to be the Ubuntu server. My domain is lab.local and management network is this. So we can have it here, right? So now it's looking good. Let me make some space. This is going to be my web server. So instead of Ubuntu, let's mention web server. So we are going to host one website, okay, and that website will be accessible from the internet. And this is my trust network. So I can do one thing. I can just make it like this. Gateway here, and we can remove some space. Okay, now it is good. So this is your trust. This is the trust machines, or you can say trust resources. This is the DMZ resource. In fact, you can add one, shape so that it will be easy for you to identify your zones. Because this is what you need to do inside the firewall. So my bad, I have to create a circle shape. So once you have the understanding of the topology, which you are going to create, send to front. So once you have this understanding of your topology, right, how it is going to look like, the same zones you can create inside your firewall. Okay, so this is going to be my DMZ zone. So let me just give it the name DMZ, and then you can host your services, inside your zone. Now let's bring one circle for trust. Okay, bring it to front. And this is so basically what happens, we are going to keep the more you know critical resources inside the trust zone, and we will keep our policies very restricted. I mean, we will not allow any inbound access to our trust zone. But on the other hand, my DMZ zone will have inbound access allowed for the public users, right? So let me just fix this orientation little bit. Yeah, so it is good now. Okay, right. And let's give it a name, trust. Okay, so it is already defined trust network. This is my DMZ. Let me just define the subnet details so that it becomes really easy to understand, how our packets are flowing. Because if the packet flow is clear to you, being the network administrator, then you will be able to troubleshoot the problems really fast. Otherwise, you will stuck troubleshooting the issues. Okay. Now what we need to do, we need to attach one more interface to this switch. So basically we need to turn off this firewall as well as the switch. So switch can be stopped right away. Firewall, we will not stop it like this because it can corrupt the image. So we will go to device, we will go to setup, and from operations, we will shut down this device. And you can also do it through CLI. There is no problem in that. There is a command. So I'll let you know later on. So you can run that command in the CLI, and your firewall can be turned off from CLI as well. So it is almost done. So if you refresh it, you will see this will become like this gray out, right? So once it is done, if you take the console, you will be able to see that, the stopping the pan software and all the demons will be stopped by the pan software. So this is the right way to stop your Linux machines. If you do direct, hard shutdown, or it's like, just plugging out the cable, you might end up corrupting the databases because Linux databases are not robust as compared to Windows. In Windows, you might turn it off directly. You might, do the hard shutdown. You will see less chances of corruption in the database. But if you do this with your Linux machines, you end up corrupting the databases. And when you're going to start your Linux machine, it will not work properly. Okay. So sending all processes the term signal and then kill signal. So it will, bring down all the daemons and then it will be shut down properly. So if you refresh, it takes time. I mean, this is the time consuming process. So if you refresh again, it is still active. So if you take the console, you will be able to see that, you know, it is still processing some information and it is down now. So power down. So if you refresh now, it should be grayed out. Mm, Still it is showing up. Yeah, it is down now. So now what we will do, we will connect this one interface with this switch and we will connect Ethernet. Okay, connected. So we have this free internet Ethernet available 1 by 5. Okay, so let me see. 1 by 3, 1 by 4, and 1 by 6 is already connected, and we have 1 by 5 available. So let me do one thing. Let me delete 1 by 3 from here. We can do that, right? So this is 1 by 4, 1 by 6. Okay. So let's go in sequence. So 1 by 3 will be connected to switch so that we can make DMZ, and this is the gateway for trust, and then you can have 1 by 5 connected to 1 by 5 of the firewall 2. Okay, so let me just make some space so that you're able to read what is written on the topology. Okay, now it's good. So let's power it on, and the gateway for DMZ would be 172.16.1.1/24. So this is the gateway IP. So we are going to configure this IP on this interface 1 by 3 here. Okay. So this will become gateway for this machine, right? So this will take some time to spin up, and once it is done, completely up, then we can log in and we can see what is going on. So it will take some time to come up. So let's pause here and then I will resume once the firewall is up. Okay, so meanwhile the firewall was coming up, so I've done some sort of arrangement, right? So this is our DMZ zone, this is our trust zone, and domain of this particular topology is lab.local, right? And I have also connected the 1 by 3 interface of this standby firewall with this switch. Later on, we are going to build the HA. So it should have the exact same connectivity like this active firewall. Okay. So now we have got this login screen. So let me just log in and then we will do the basic configuration. Meanwhile, what I have also done in this Linux machine, I have updated the IP address. So if you just check it out here, so you will be able to see that IP address is now 172.16.1.2. So if you type if config, you will be able to see the interface IP address, and this has been updated. Broadcast, net mask, and gateways were 16.1.1. And right now, if you try to ping your gateway, it will not respond. Reason, we have not configured that interface in the firewall, so it will not respond, right? So let's go to this firewall and configure the IP address on Ethernet 1 by 3 as 172.16.1.1 and create a new zone, DMZ zone, and attach that particular interface to that particular zone. So if you go here, go to network, go to zone, and create your DMZ zone. It is already created. I think we created yesterday. Okay. So we just need to attach it. So inside the interface, 1 by 3, the interface type is HA. So we need to make it layer 3, comment DMZ interface, and then in config virtual router default we will be using security zone will be DMZ, which we have created yesterday. IP, click add 172.16.1.1/24. Then advance, you can have management profile ping only so that it can respond to the pings. So if you are not going to attach this management profile where ICMP is allowed on the interface, so your firewall will not respond to the pings. So by default, it doesn't listen to any network services. Okay. So be it HTTP, SSH, or ping, you need to attach the management profile, then only it will work. So to create the management profile, you need to go to network. You need to scroll it down to network profiles, and here you have interface management, and here you can create the profiles, right? Whatever you would like to enable on that particular profile. So now, meanwhile, this commit is in progress. So if you go to Linux, it will respond back. So let me just show you that website which I have hosted. So if you go to this directory var www html. So I'm running Apache server here, right? So if you see my HTML file index.html, so you will be able to see that we have this website, and once user is going to hit this web server, it will be served with this particular web page. Welcome to cybersecurity, author anonymous. Okay. So let's say we can add, you know, so let's close this file. Let me show whether it is working or not. So if you open it in the same machine, if you hit the loopback address, that is localhost on port 80, so you will be able to see that web page. So if I will type http 127.0.0.1, so I'm hitting on port 80, so you can see this web page is available. So I've also created the DNS record for this. It has failed. So let's see why the commit has failed. Device config HA interface is not allowed keyword. Okay. So we were using that interface for high availability. So that's the reason we are not able to change it. So first we need to modify the configuration. So 1 by 3 was used in HA communications. So we need to remove it from here. You can see here Ethernet 1 by 3 being used as. So to change the settings, first you need to enable the HA. Once you enable it, Port is invalid. Just correct the port. We have connected Ethernet 1 by 5 as per the topology. And if I go to network, 1 by 5 is HA. In fact, 6 we will do for active setup. So in HA, in Palo Alto, we have two high availability options available, active passive and active. So now this looks good to me. The configuration is updated. And let's go back here. And now if you try to enable it, it will enable without any error, right? If you do OK, it will be enabled. So, but we are not going to enable the HA right now. We will do the configuration later on. So let's commit the change. So now it should complete. So I was telling you this that for this website, I can access it over internet. So I've created the DNS record, and right now if I'm going to hit this DNS entry cybersec.local. So as of right now, it is not taking any hit, or we are not able to see the website. Reason being that if you do the troubleshooting, you get such cases when you are in support that this inbound access to this web server is not working. Users over internet are not able to access this web server. So to begin troubleshooting, first of all, you can take the Wireshark captures on the user machine to see, what is the user IP, what packets it is sending since INAC, TCP three-way handshake will first start. And then on the firewall, you can simply go to monitor, and in traffic, you can apply the, source IP. So if I will go and check it out, what's my IP? So you will be able to see. So my IP address right now is this. So let's check it out. Are we receiving any, you know, packet from this IP? So if I will apply this filter, so it is showing that we are receiving the packet. You can verify the date and time. So it is quite long, I mean, quite ago. So this traffic has not hit. Okay. So let's go incognito because this is port 80 service. So let's go incognito. Test.cybersec.local, and now you can see are we getting any hits, and you can also keep it 10 seconds so it will automatically refresh after 10 seconds. So we just need to understand whether we are receiving any hit or not, right? And we can see the destination IP for this server is 10.1.1.3. Although in customer environment it will be the public IP configured on the outside interface. I already told you that I have one firewall ahead of this topology, right, which is doing NAT for me, and it is translating this IP to private, and that's the reason I'm able to communicate. So now this 1.1.3 is just hypothetically we are assuming that it is a public IP for us. So you can see that I'm not receiving any hit from this IP. So let's do one thing. Let's see, do we have any hit count for this destination IP? And service port is going to be the port 80, right? So for this destination socket, you can do the match. Do we have any hit counts? So right now you can see that since 24th February, we don't have any hit count. So it means the firewall which I was talking before is blocking this connection. So let's log in into that particular firewall, right? And let me show you. So remote host one, okay, login. So we are inside the perimeter firewall, which is controlling everything. So let me just verify the NAT rule. Web server interface, it is allowed, right? So web server show run object ID. So it is sending the traffic towards this. Let me verify the route. And we do have route available. So if I'm going to ping 10.1.1.3, the outside interface, let's ping ping DMZ is my 1 by DMZ interface is 1 by 3. Yeah, so DMZ destination IP address 1.1.3. So we are not able to ping this firewall outside interface. Let me verify, do we have profile attached to it? So ping is already attached, but I'm not able to ping it. This commit is successful. Let me verify if this Linux is able to ping its gateway, right? So terminal ping 172.16.1.1. So we are able to ping it. Now internet will not work for this machine, right? So if it will try to communicate with internet, it will not work because we don't have any security rule configured or NAT configured for this subnet. Okay, so let's go back. Okay, so now we have the rule active. So the strange part is why my PC is not sending packets to this particular IP address directly. Uh, Let me hit to the DNS resolution and should be working. Let me hit to the public IP directly. So let me pause the recording to hide the public IP. Okay, so I have checked inside my infrastructure firewall and I can see that sessions are coming in from my source IP towards this destination IP, and you can see the timings, right? So sessions are coming in and it is allowed in the infrastructure firewall. But here we are not able to see the logs. So it might be possible that default rule logging has been disabled. So might be the reason, it is not coming. So to highlight your policy actions, you can select this. So it will only highlight, where the packets have been dropped. And you can also click on resolve host name to see if any IP address can be resolved into the FQDN to understand, where the traffic is going. So let's do one thing. Let's do the basic configuration first, right? And then we will do the troubleshooting from, because this is the infrastructure firewall. And if you see in the Eve topology, gateway is 10.1.1, and this gateway is configured here, right? So this entire Eve topology is behind this particular infrastructure firewall, right? And it is also behind this another firewall, right here. So there are multiple firewalls to secure this infrastructure because it is hosted over internet. So we receive multiple attacks, So that's the reason. So it is taking hit. So let me just do one thing. Let's do the configuration first. So this Linux is able to ping the gateway. Internet access to this machine is not required. We just need to allow the inbound access. So now to do that, what you need to do? So you have already configured your zone, you have already configured your interface. So you need to allow one security rule and you need to configure the NAT to allow this connection, right? So inside the security rule, you need to give it a name, web server access, right? And then you need to define your source. So my source is going to be the untrust. Packets will be coming from outside. My destination is going to be the DMZ, right? And destination address, if you need to allow any particular subnet only, that you can define, right? So let's define web server and IP address is 172.16.1.2. So I need to allow this IP only, and application any service any action, so it should be allowed. But now we need to apply the security profiles, right? Because this is the inbound access and attackers will also try to access this particular website, so we need to apply the security profiles. So right now I will go with the default ones, and later on we will see how you can configure your profiles as per your business need. Okay, so anti-spyware vulnerability, antivirus, URL filtering is not required. File blocking we can configure strict. Data filtering, wildfire analysis, we can do default, right? That's it. Okay. So once you define these policies, you will be able to see this. These policies are active, these security profiles are activated on this rule. Okay. And now we need to configure the NAT rule. Basically, we need to create the destination based NAT, right? So you need to click on add. You will give it the name web server access. Original packet will be coming from the untrust. Destination zone is going to be my DMZ. Destination interface is going to be 1 by 3. Service, you can keep it any, or you can make service specific rule as well. So service HTTP, right? Source address will be internet based address, so it could be any. Destination address is going to be 10.1.1.3. Okay, so this is going to be the destination address, and translated packet is going to look like we are going to do the destination translation. So now you have option static IP binding, or you can do dynamic IP with session distribution. So you'll go with static. Translated IP will be web server, right? So translated port not required. Click OK. So if anyone is going to hit on this particular destination IP on port 80, then it is going to do the translation to this particular web server IP address which we have defined, right? This is the destination based NAT we have created. One mistake we have made, it will be untrust to untrust. Source zone and destination zone will be untrust to untrust. In Cisco, it's like pass through, but in Palo Alto, because source packet is coming from the untrust, and this destination interface is also present in the destination zone untrust. So that's the reason in Palo Alto this is the way of doing it. Okay, and my destination interface is going to be 1 by 1, right? Otherwise, this rule would have not taken hit. Okay. So for destination inbound rules, you need to keep one thumb rule in your mind. Pre-NAT IPs, post-NAT zones will take the match. So I'll repeat this thing. Let's initiate the commit first, and then I will repeat what I mean. So pre-NAT IPs, post-NAT zones. This is the lookup done inside these packet processing. So pre-NAT IPs, if you are creating a security rule or destination based connection, where your destination IP will be modified, so you need to enter inside that security rule pre-NAT IPs and post-NAT zones. So after natting, what will be the zones? Okay, so these two things you need to take care in your mind when you're creating the security rule, otherwise your security rule will never take it, right? So let me explain it again. So when I have created this security rule, what I have done, so web server access, Although here I have kept, everything like sources like any, right? And here, so pre-NAT, if you see destination, what IP I have configured here, let me just check. Web server. Okay, so it is not going to take hit, right? Reason being that we have given the actual NATed IP, right? So this security rule will not take hit. We need to do the modification here. So instead of web server calling web server here, we need to have the pre-NAT IP. So before NATing, what would be your IP address? So it is going to be the 10.1.1.3. Okay. So pre-NAT IPs and post-NAT zones. So NAT zones will be after NATing. Okay, so that's the reason destination I have made DMZ. So this is the small correction we need to make here. Just complete. Let me commit this change again. So to explain it in a better way, so try to understand this in a fashion. This is your Palo Alto firewall, right? This is your firewall. This is the interface. It is having this particular IP. And we have this DMZ interface where we have this particular server available and server IP is this. Okay. So now when you are creating the security rule here, so what you need to do, you need to consider the pre-NAT IPs. So in destination, I will enter this interface IP address. This is what I have done. And post NAT zones, I mean after netting, what will be your zones? So this is my untrust source and destination will be my DMZ zone, right? So this is how you define your security rules. So let's see, this is done. And if I go to monitor and let's check it out if you are able to see any traffic coming in for this particular. So you can see traffic has started coming in for this particular website, right? And why intrazone is allowing this communication? Hmm. Okay, because untrust to untrust is allowed and we have the rule, so it is going in, right? So I need to make sure that we should disable that rule, because it is taking hit. This intrazone is allowing this connection, although NAT will not take hit for that, right? So let me just do the testing. Test.cybersec.local. So you can see the web page has been displayed on my browser. And if you see the hit counts, so if you refresh, you will be able to see the hit counts on this rule. You can see 3 hit counts. And if you go to NAT, you will be able to see the NAT hit counts as well. So if you refresh, so what we are going to do in coming videos, we will do the brute force attack. We will do the attacks through Kali Linux on this website, and we will see how these security profiles will be able to save our server from the cyber attacks. Okay, so hit count you can see it is taking hit, and if you go to monitor and inside monitor you will be able to see my IP address, right? And it is establishing the connection. Okay, web browsing allow, and you can see. So as a best practice, since we have such a requirement where destination based NAT is also required, you can see untrust to untrust, it is also getting allowed. So this IP got NATed to this IP. I mean, source was this, destination was this on port this, and this session also got allowed, right? Because of the default rule. So if I will open it up, so intrazone is taking hit, right? And you can see zone destination IP is this. Although this connection was not established, right? But as a industry best practice, what we do, we generally disable these two rules. I mean, we don't allow it. We keep intrazone and interzone rules to block the communication, and then we manually create our rules as per the requirement. So what we do, we override this action, right, to disable. So you see this gear action, right? So if you click on it, I mean, if you click override here, you can override the action and you can click deny, log it session end. Okay. Okay. So now what we are doing, that if trust would like to communicate with trust, that communication will not be allowed, right? So we need to allow that rule. So we will create one rule, inter VLAN or inter default intra zone, right? So source is going to be trust. If somebody from trust would like to communicate to somebody in trust, right? So that will be allowed, right? And we are going to log it session end, right? And since this is the intra communication only, rest of the traffic will be like deny only. So we will also create one cleanup rule. We call it cleanup rule. So initially in production environment, we have permit IP only to analyze the logs, right? To analyze the logs. So source is like any, destination is like any, okay? Any. Action will be drop. We do it after analyzing the logs for few months, or not for few months, at least for 30 days, because when you're designing the policies for any organization, you're not sure what type of traffic is there, right? And already we have these two rules in place, but generally we disable the logging on these two rules because we don't want these default rules to be taking hit. So you can create your own cleanup rule, and you can initially you can allow the traffic, but later on we can do the log analysis and block it. So in my case, I will deny all. So only allowed traffic will communicate. Rest of the traffic, if it is not going to match these rules, it will be dropped. So deny. So we need to understand these actions as well. So in the next video we will more talk about the security policy, right? So we will discuss about these actions, what happens in deny, allow, drop, recent client, and all that stuff. Okay. So let's have this rule at last. So deny all, right? It is going to drop the packets. If these rules are not taking hit, then deny all will take hit and it will drop the packet. I mean, we are just following the industry best practices so that we can minimize the attack landscape. Because when you talk about zero trust network access, you need to analyze the attack landscape, and accordingly you need to you need to create the network segments, and you need to create your policies to allow the communication, right? So the more granular control you have over your network segments, the more safe you are making your network. Because If your attack landscape is wide open, I mean, let me just take whiteboard help to explain this concept. So if it is like this is your firewall, and we have multiple zones available. You know, this is trust, this is DMZ, right? This is untrust. So you are doing the network segmentation basis on these zones. Let's say we have an environment where everything is inside trust and outside is in untrust. That's it. Only two zones. So what will happen if any attack is coming in from outside? It can go to various places because your attack landscape is wide open. You know, you might be having your critical servers also available here, right? And that is the reason in our topology, what we did, we put the critical infrastructure behind the trust zone, and the public servers, or you can say the web servers, we put inside DMZ. So that we are saying that if anybody is coming from internet, that traffic will go to this route. And then we can place our honeypot servers to mitigate the attacks, right? They cannot access, I mean, they cannot take this path because we have not configured any rule. So if you are not going to open up the ports or open up the security rule for any connection, that will be by default dropped or denied, right? Because this is the basic fundamental of the firewall. So if you don't have any rule to permit the connection, it will be dropped. So this is how you can see with the help of the network segmentation, you minimize the attack landscape. Okay, so this is done. Let's see if any traffic is hitting this deny all, and you can see it is increasing. Deny all is like, you know, getting increased. And if you go to monitor, so you will be able to see because we have highlighted the policy action. So it will be all pink, right? It will tell us what type of traffic is getting blocked. And you can also check for the services if any services are down, right? So you can see that your web server is trying to communicate with the DNS, right? So your queries are going outside your infrastructure, right? And we should not allow this. You know, as per best practices, your DNS traffic should not go outside your domain, your infrastructure. It should be resolved within the local subnet. Okay, so we will discuss this in more granular details. So basically, this is the traffic which is getting blocked, right? So it is coming from DMZ and trust. We don't have any security rule configured, and continuously this Linux is trying to resolve few, you know, FQDN. So it is continuously sending DNS packets, and it is getting blocked, right? So this is how we do the troubleshooting, and this is how we configure the inbound access to any particular server within your topology. So thanks for watching this video. In next video, we will see how you can configure the security rules as per the industry standards, what actions we have available inside these rules, and then we will understand the security profiles. So thanks for watching this video.